Alright, this is surgical medic on your screen, and we will be going into chemistry. Alright, the very first thing you need to know in chemistry, the foundation that you need to master, so that the rest of chemistry would make more sense to nature of matter. Alright, what is matter? Actually, matter is anything that has a mass and occupy space. Look at this. Let me call this a ball. This ball occupies a space. Okay, let me call this is the space the ball occupies. Like the ball is inside a bowl. Let's talk professionally. A beaker, alright? So if this ball is inside a beaker, then that ball is considered a matter. Why? Because the ball is actually occupying space, and the ball itself has what? A mass. So that's why you see that almost everything, or let's even say everything on earth is made up of matter. Now, for example, plants and animals, we are actually the one that even dominates the world. Even as we dominate the world, we are what? We are matter. Are you with me? If even the food we eat, the water we drink, these things are matter. Are you with me? So we ourselves are what? Are matter. Are you with me? Now, the mass of an object is the quantity of what? Of matter contained in a body. He said matter is anything that has mass, right? Now, look at this ball here. Let's draw it out again. A ball. So now, the ball here is actually having what? A mass. What is this mass that we are talking about? We're actually talking about the quantity, the quantity of this matter inside this ball is what is called the mass. Are you with me? Now, the mass here is measured in what? Kilogram. We explained this in physics in the previous video. The mass is actually the quantity of what? Of stuff. Are you with me? The quantity of what? Of stuff contained in a what? In a body. Contained in a body. I use, don't forget what you are looking at too. We are using this ball as an example. So, and we found out that this ball is a matter. Are you with me? This ball is a matter. Why? Because it has a mass and it occupies space. Alright? So now, what is now the mass? The mass is the quantity of this matter. The quantity of this matter inside this body, quantity of stuff. For example, now, okay, let's say this is you now. Are you with me? This is you. Now, you are having mass. Let's say you have mass of 30 kilogram. We use kilogram in physics actually, but in chemistry, you're actually going to be using mole. So here, me saying kilogram, I'm not correct because we use this in physics. Are you with me? Mole would be our unit of mass in chemistry. Are you with me? Are you with me? So, alright. So, for me saying that this person here has a mass. Are you with me? And where he's standing is the space this person is actually occupying. So, in short, this person is a matter. Are you with me? Because matter is anything that has mass and what? Occupies space. And what? Occupies space. Now, what is now my mass? I'm trying to figure out what this mass is. For this person, the mass is the quantity of matter contained in this body. Or let's use another word, the quantity of stuff. Okay, now in this person is actually having a digestive system. In this same person is having a skeletal system. In this same person is having a nervous system. In this same body, you see a lot of things. A lot. You see your organs and everything. Alright. So the quantity of all these things All these stuffs in this body is the mass, which is now measured in what? Mole. In what? In chemistry. So coming to, if you are saying kilogram in chemistry, you are very wrong, because we use kilogram in physics. So the SI unit, please take note of this, is what? Mole. Are you with me? I almost made a mistake before. You get? So alright, please. So for practical purpose, we would say it's measured in kilogram sha. For practical purpose, using your weighing balance. And in physics, when I was explaining, I remember very well that I mentioned what we use to measure the mass of a body from my MBBS. I explained this very, very well. This mnemonic, I explained it very well in, under what topic is that? Measurement and units. Are you with me? I said M here is our mass, while the BB here is our beam balance. That means beam balance is actually going to measure the mass of a body or an object. Are you with me? Are you with me? So, alright. So in general, alright, matter is built up of, one or more elementary particles. What are these elementary particles? These elementary particles are the particles of your what? Your atom, your molecules. Are you with me? And what? And ions. Chemistry is what? Simple. So we say that atom is actually matter is built up of one or more of these. One or more of what? Of these. Now let's now take them. Let's see. Before we go into all these things in chemistry, there are key things we need to know. Are you with me? There are key things we need to take care of, like our properties of matter, our physical change, our chemical change, our element, compound, and mixture. Now let's go into them one after the other. One step at a time. Now let's go into the properties of matter. Let's just manage this side for the properties. So let me start from here. The properties of matter. Alright, now the characteristics that actually define, a particular substance is called properties. Like, what can you see in this ball? What physical thing can you see? Okay, what can you even say about this ball? Okay, the ball is spherical. The ball is actually heavy. The ball is color red and black. So all these things that you can say about this ball is the property of this ball. When we say property of a matter, this ball is actually a matter. Why? Because it has what? Mass and occupies space. Now, if you are not asking me now that, okay, what are the properties of this ball? I can look at this ball and say a lot about it. So that's what I want to look at here. Now, are you with me? So, substances can be identified by what? By the characteristics they actually what? Possess. So now, let's look at a few things. We should look at a sugar. Yeah, we should look at a sugar. We should try to look at iron. And we should try to even look at metals in general. So we'll try to look at all these things. Are you with me? Alright, so firstly, let's look at our sugar. Our what? Our sugar. So our sugar, for example, now, you know that your sugar is, firstly, you know that this is a matter. Because anywhere you put this sugar will occupy space. And this sugar is actually even like, it's having a mass. It can be maybe, you can weigh it and have something like 10 kilograms or more. So that's enough proof that sugar is a matter. Now, what are those things you can see? Are you with me? Give me a few minutes, please. This one. So yes, I'm back. Sugar. What can you say about sugar? You are trying to look at I said the characteristics that show us, or let's say substances are being identified by the characteristic they possess, right? So this is what is called the property. Let's look at what identifies sugar. What the characteristics of sugar. So telling us about the properties of this matter, of this particular matter. Now, the very first thing you will say about a sugar is that a sugar is white. Are you with me? A sugar is white. A sugar is crystalline, yes, because it's made up of what? Something like a crystal shell. Are you with me? Then it's a solid, alright, you can add it to white here. Alright, then what can you still say? Decomposes on eating, yeah, and can be recovered from evaporation. So all these things I'm saying that I can say about sugar are the properties of sugar. That's sugar for you. Let's go into ion. So this ion is a type of what? Of metal, and we see a lot of things under this ion. Are you with me? Because for example now, under metals, we know that metals generally they have some characteristics they possess. Maybe their lustrity, their ductility, their what's it called? Their sonorous nature, yeah, and all of that. So under ion, we say that ion has metallic luster, meaning that it's shining, and its surface would reflect light like metallic luster. Are you with me? Then what can we still say about iron that we can see physically? We say that it would actually leave a red deposit when it forms rust, or when rust is on it, it will form a red deposit, and this due to rusting and all. Then what can we still say? It can be magnetized. It can be magnetized. Are you with me? So all these things I'm talking about are properties. So we can see, like, what can we say now? We can see that physical properties are properties that are associated with your physical change. You get your physical change, things you can see, things that you can see. Are you with me? So, and the common physical properties of a substance would actually include something like the boiling point, the melting point, something like under metals you have something like the ductility, conductivity, sonorous nature. All those things are physical properties. Coming to water, you can tell us about its boiling point, its melting point, you get, and such as properties that is like that may be detected by our senses. So these are something like color. Let me just manage somewhere here. Our color, our odor, and taste. So these things, they can be like detected by our senses. So we see that these things also are actually defining a particular matter. So we see that they also are physical properties. Are you with me? So I think now we should move to physical and chemical change. So we see that matter undergoes changes, and these changes might be easily reversible or not. We have the physical changes, we have chemical changes. So now matter undergo changes. There are some that would be some changes that would be easily reversible, and there would be some changes that would not be easily reversible. Are you with me? So alright, let's take them one after the other. So we'll be going into this first. Alright, we'll be going into this first. And now, what is physical change? Physical change is simply the one that is easily reversible. Are you with me? Easily reversible, and no new substance is formed. no new substance is formed. Are you with me? No new stuff. It will not form new stuffs. Are you with me? But chemical change here, this is the one that is not easily reversible. It's not easily reversible. So it's only the forward reaction that is noticed, that we can see. So, and new substance is actually formed. New stuff, yes. New stuff is formed. Is formed. Like new substances is what formed. Are you with me? So, alright, now let's now try to identify, or let's recognize between both of them, the examples under physical change and those ones under the chemical change, in such a way that you would never forget again. Now, physical change, alright, every change of state, please take note. Under physical change, the very first example you should take note of is your change of state. Anything that is changing state, are you with me? Anything that is changing state is a physical change. Maybe you are having your from liquid to gas now. You know that liquid to gas is something like evaporation now. You know all these things before. And your gas to liquid is condensation. So when we get to change of state, you would understand all these things better. But let's just term it generally. Change of state. So anything that is actually changing state, changing from one state to another state, is actually a physical change. A physical change. Now let's check another example. We have the solution of salts. So anywhere you see the solution of salt, just rush to that option and take and choose the physical change. Are you with me? Physical change. Because this dissolution of salt, you know that if you are trying to dissolute salt, when you add, that's when you are adding salt and water together now to give you what is it called, a salt solution, in which this one is your this will be your solvent, the one that will dissolve the solid, and the solid itself will be your solute, while this will give us a solution, meaning that your solute plus solvent will give you solution. We'll deal with this very well under solution. Are you with me? Follow closely, one step at a time. So salt here plus water will turn into solution, and you can get your salt and water back from your salt solution, meaning that from your salt solution you can go back to your salt and water, and that's by evaporation to dryness. If you evaporate that salt solution to what? To dryness, you will see your salt and water back. So as you can see, it's easily reversible. You can reverse it. You can reverse it back to this very fast. As you can see, you can reverse it back very fast. Sure, you get. So that's why it's a physical change. It's a physical change. So it's actually going back to salt and water. There is no new stuff. There is nothing new about the salt and water that is still forming again. It's just a reverse. Are you with me? So the solution of your salt, and then you have something like we have separation techniques, Abi, that where you'll be reading your flotation, your decantation, your precipitation and the likes, your fractional distillation, your separating funnel stuff and all of that. So all these ones also are physical change. Please take note. When you see anything, maybe any question coming from, okay, which of these are examples of physical change? If you see anything separation techniques or separation of mixture in your option, just run and choose it. Because you cannot say separation of mixtures is example of a chemical change. No. It's a physical change, because we are trying to obtain pure stuffs. Are you with me? So take notes. Under physical change, you have your separation of mixtures as another example. Then you have magnetization and demagnetization of iron rods. Then I think that's all. So let's go to that of a chemical change. A chemical change. So as for chemical change, I said this, that a chemical change is the one which is not easily reversible and new substances are being formed. For example, your wood now. If you have a wood would actually burn, will give out what? When you are burning wood, like you are trying to burn it, or you are, let's call it burning, you are not even trying, you are burning a wood. So the wood would, like, it will begin to burn, slowly, giving out heat and light. Are you with me? Heat and light, to give out heat and light. So during the process of burning, the wood will be disappearing in small small. Then at the end of everything, what we will see is little ash plus gases. So this is what wood will turn into, ash and gases. Can you reverse ash, like all those ashes and gases? Can you reverse it back to wood? No, you cannot. So burning is a perfect example of a chemical change. I think with this explanation, I don't think you even need to, you can't even forget it again. Are you with me? Burning is an example of a chemical change. Let's look at another example. We have rusting of iron. Are you with me? Rusting of iron. So when iron rusts, the rusting of iron is due to when water and moisture is actually like our water, you get our water and moisture from the atmosphere, or stuff like that, is actually affecting that metal involved. So there will be a rust, new substances are being formed. So this rust is actually the new substance that is being formed on that iron. Are you with me? So, and can you reverse it back to iron again? No, you cannot. So that's why rusting is a perfect example of a chemical change. We have addition of water to slake lime. We have many more examples. Are you with me? Addition of water to quicklime. You can call it slaking of lime actually. And then we have fermentation and decay of substances. When substances actually decay, they will give rise to new stuffs. For example, your bread. If you leave your bread inside the house for, let's say, 7 days, the bread would have grown something like fungi. You get stuffs would have grown on that bread. And trust me, these stuffs that grew on the bread is a new substance. A new substance is being formed on that bread, and this is due to the decay of the bread. Are you with me? Now, can you now turn this decay, this growth on the bread, can you reverse it back to your normal bread and go and eat it? How now? Even if you reverse it, if you see it to reverse, can you eat it? No, you cannot. And it's not even possible for you to reverse it still. Are you with me? So decay of substances and fermentation of substances is a perfect example of a chemical change. Are you with me? Are you with me? Then now there is something that I would like you to know also in addition. The changes that we see in an electrochemical cell actually is another example of a chemical change. So we are done with physical and chemical change now. I think we should move to elements, compound, and mixtures. Elements, compound, and mixtures. All right, here we'll be looking at these ones also. So elements, compound, and mixture. So let's take care of elements first. What is element? Element is a substance that cannot be split into simpler substance by ordinary chemical process. Are you with me? By ordinary chemical process. What do they mean? For example, you have your hydrogen. Can you split hydrogen? No, now you cannot. Can you break it down? You cannot break it down. Can you break chlorine down? You cannot break chlorine down. Another elements that we know. Tell me one. Iron. Let me stay within the first strength elements that you guys know very well. Your sulfur. Can you break it down? No. But coming into, let's go into a compound now. If it's a compound now, you can actually break down. For example, NaCl. You can break NaCl down into Na and Cl. Are you with me? You can actually break H2O down into H and O. That's 2H plus O2. Are you with me? Are you with me? Then maybe you are having something like H2SO4, so you can actually break this one down to 2H plus SO4 2 minus. Don't be okay. Let me come into simple this thing. H2SO4 can be broken into hydrogen, sulfur. Are you with me? And oxygen. Are you with me? But coming into elements cannot be broken into simpler units. Never. You cannot. So that's why the definition says it's a substance that cannot be broken into simpler units by ordinary chemical process. So now, and under this element, scientists actually discovered plenty elements. Let's estimate it. 109 elements was discovered by the scientists, but just this 9 and 0, just 90 of them is actually being prepared in. No, sorry, just 90 of them is found naturally. While the rest is being prepared. The rest is being prepared in the laboratory. So that's that. And this element is actually grouped well in the periodic table. We saw how Mendeleev actually grouped in order of atomic mass and all of that, and the recent classification where they have been arranged in order of their increasing atomic numbers. So they are actually arranged in the periodic table, and because of this, we have we're able to get the types of elements that we have, and we see that there are actually there's actually six type of an element, which is number one, you have your reactive elements. We have your non-reactive elements. Should have your actinide, call it actinide. We have our lanthanide. Don't worry, under periodic table we'll talk about all these things very well. We'll go deep into it. Lanthanide. We'll have our pure, I think 1, 2, 3, 4, we need 2 pure metals. Are you with me? Then would have what's that? So noble gas. Yes, there is noble gas also. These are the 6, I think. These are the 6 actually. So reactive elements, non-reactive, actinide, lanthanide, pure metals, and noble gases. These are the 6 type of elements that we have that is being grouped in the periodic table. But normally if you want to group elements, like let's just group it in a simple way. You get in a simple way, we just say element is grouped into metals and non-metals. Let's write it to metals and non-metals, then metalates. These are the semi-metals. This is how you can also classify them. Are you with me? So, alright. Um, Now, metals, let's see the differences between metals and non-metals. Let's see. What are those differences that we can see? So then after that we go into compound. Compound. Right. Now, differences between metals and non-metals. You need to understand what they are first, even before going into their differences. What are metals? What are metals? Metals are, you know that they are the one that they actually used to carry plus now, and then you know your non-metals are those that used to carry minus. You get? So since metal is carrying minus, we will not say it's gaining, no, because in English now plus means somebody is gaining, but in chemistry reverse is the case. Here we will say the metal is losing electron. Are you with me? So the process by which a particular, let's say an element, or let's say let's call it element. Now an element is losing electron. Are you with me? That's telling you that that element is a metal. Okay. Yeah. So that means metals would ionize by what? Electron loss. Why that of non-metals? You know, I told you negative in English means you are losing, but in chemistry, no, we call it gain. So non-metal would ionize by electron what? Gain. Are you with me? So these are the difference. Now, example of metals now. Let's check. We have something like calcium, you have a magnesium, you have a potassium, blah 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 blah. Now, this is how they were nice. Now when you have your CH, to give you Ca2 plus 2E minus, same for magnesium. It's actually losing electron. When it loses, it's carrying Mg2 plus also, and 2 minus will come here. Then potassium, which will be K plus E no minus. All these things, they are very very simple. Yeah, they are very very simple. Let's try to even check how we got them. So here, I said Ca is actually going to lose. How do we know that this? How do we know that this Ca is actually losing these two plus that we write? How do we know? From your 288 this thing, your KLMNO configuration. If you try to write the configuration of calcium, the configuration of calcium will now be your, you know that calcium is 20 now. It will now be your 8 to 16. 8 plus 8 is 16, plus 2 is 18, plus 2 is what? 20. So you see that this number is very small, so it has to lose it out. It has to lose it out and then give another one that is having plenty. Are you with me? So that means that it will be carrying plus 2. That's why the C here is carrying plus 2, and in which it must lose it. That's why you have plus 2E minus. So you should be able to do for magnesium, potassium, and many more metals by yourself. Now, example of non-metals, we have our chlorine. Chlorine, which would actually gain. That would be, no, sorry, chlorine. So it said process of gaining electron, right? So this chlorine should gain. That's plus E. Are you with me? And since chlorine is 2,8 what? 2,8 what? Chlorine is how many now? I think chlorine is 17 now. So 287. So yeah, remain what? What remain? What will you add to 7? That will make it octet. That will make it 8. 1. So that means it has to collect 1 from a metal, shake it to become 8. So this one that is actually collecting me, it's actually gaining the 1. So that's why it's carrying the E raised power minus. Are you with me? It's gaining here, but in chemistry we call it like it's losing. It's losing in it's gaining. It's gaining. Since it's minus, it's actually gaining. So now write it in form of minus here, because in English minus means lose, but here we use it as gain in chemistry. So this one will now be written as -1, but professionally, don't put 1, just put your minus. They know what you are saying, that is -1. So thereby giving us our normal chlorine. Are you with me? So now let's check for the differences between metals and non-metals. For the first thing is their physical properties. Their physical properties are actually very, very different. For example, now under metals, you see that metals are actually, malleable. Metals are malleable. Metals are ductile. Are you with me? Metals are ductile. Metals are sonorous. They have metallic luster. You get. So when you get to metals and their compound, you would understand this very well. You understand this very well. So malleable is just telling you that this one, like metals can be hammered into sheets, and you can hammer them into sheets. Then ductile is actually telling you that it can be drawn into thin pieces. For example, your copper wire, you can actually draw it. It can be drawn into thin, wires and all. Then sonorous, then your luster and all of that. Now let's now check for non-metals. You see that non-metals are non-malleable. They are non-malleable. They are non-ductile. They don't conduct also. Their conductivity is 0. Are you with me? But here they conduct well. So here they lack metallic luster. They lack it. They lack metallic luster. So let's check another difference. Metals actually would have, great strength. Metals would have great, let's call it tensile. Let's talk professionally. Great tensile strength. Why that of non-metal, they will have low tensile strength. Then they have, that metals normal now, they will have high melting and boiling points now. High melting and boiling points, IMP and BP, high melting point and boiling point. Why non-metals will have low melting points and boiling points. Are you with me? Low melting points and boiling points. Then another difference is their density. Their density, metals is actually going to have high densities, while non-metals would have low densities. Then talking about conductivities, you should know that metals would conduct electricity, while non-metals would not conduct electricity. And I think with the exception of graphite, yes, I think graphite would actually conduct. So alright, I think that's that about our elements. We've talked about our elements, how they are grouped in the periodic table, the types of elements we have, then metals and non-metals. Let's journey further. Let's launch up to mixtures. No, sorry, compound first. Compound first. Compound. What is a compound? The compound is, as a result, is formed from the combination of 2 or more elements. So if you have 2 or more elements that is chemically combined together, that's a compound. Are you with me? For example, your hydrogen plus chlorine now will give you HCl, alright, hydrogen chloride, alright. So this hydrogen chloride is the compound here, and as a result of 2 elements combining together. If you now have your maybe H2O plus Cl, that's you having more than 1 element combining together. Now have your HOCl. Are you with me? HOCl, but think we should now put Cl should be Cl2, then should continue like this. That will give us our hydrogen is what 2, oxygen is 1, chlorine is 2. So this is a compound here, and it's being formed from combination of our elements or compound. So what is a compound? A compound is a substance that contains two or more elements chemically combined together. Chemically what? Combined together. Are you with me? Chemically combined together. And now you know that this is actually coming from physical change now. Like when they said a chemical changes to one which is not easily reversible, and in which new substance is being formed. So here the new substance formed here is HCl from the combination of hydrogen and chlorine. Are you with me? And now this new substance that is being formed would have like the properties would actually be totally different from its component element. You know that hydrogen has a separate physical property, then chlorine too have a separate physical property. So if you mix it together, if you mix the two of them together, it's not as if their properties would like be retained. No, it will not be retained. So here you know that another substance is being formed, which is a compound, and this compound would have a different chemical, let's call it properties. So it would have different properties from that of its what component element. Are you with me? Please don't forget, should code it in to your memory, and they would always combine in a fixed ratio. Are you with me? So you have to understand that, and then we have series of examples of a compound. So we have let's look at few examples. We have our salt. Salt is our compound now. Let's use our table salt. Our table salt is coming from combination of sodium and chlorine. So this is your salt, and your salt is a what? A compound. And what is a compound? A compound is a substance formed when two or more elements combine chemically together. So sodium and chlorine combine together to form sodium chloride, and our sodium chloride is a salt, meaning that this sodium chloride is a compound. Let's go into another example. We have our washing soda. Our washing soda, this is the formula of your washing soda, 0.10 H2O. So this is example of a compound, again coming from the combination of your sodium, your carbon, your oxygen, and your hydrogen, and they are all in a fixed ratio. So it's a perfect example of a compound. So, and there are many more. You know it too. Maybe when you are having your ethanol, you are having your caustic soda, your sodium hydroxide, that's your caustic soda, your hard soap. Are you with me? Your sugar, your limestone. Let's do for sugar and limestone before we move on. For example, sugar is, let's use C6H12O6. Let's use our glucose. So you can see that this is a compound too, and it's actually coming from the combination of your carbon and hydrogen and what? Oxygen. So it's proving to us that it's a compound also. Now let's check another example. Our limestone, before we now progress. Our limestone is our CaCO3. As you can see, calcium is combining with carbon and 3 atoms of oxygen to actually give you your compound, your limestone. Yeah, we call it limestone. Limestone. Are you with me? So let's go to mixtures. Mixtures. What are mixtures? So here, mixtures a substance that contain two or more constituents, that can be separated by physical method. That's where our separation techniques is actually coming from. So mixtures, are you with me, would contain two or more constituents. For example, let's cite an example. Your air is a mixture of gases. Air is actually a mixture. Are you with me? Air is a mixture, and inside the air would see oxygen, would see a nitrogen, would see a carbon dioxide, would see a noble gases, and noble G, that are noble gases, would see dust, and would see moisture. So all these stuffs are the stuffs that are contained in the air. So, and we call all these things constituent elements. Are you with me? The constituent element or constituent composition of the air. That's why we define mixture as, that substance that contain, two or more constituents that can be separated by physical method. When we get to separation techniques, you'll be able to understand what we mean by can be separated by physical method very well, because we'll be applying the stuff under separation techniques. Alright, so now let's look at few examples of a mixture. For example, now you have your air. I've explained the air already, and I've shown us constituent elements. Let's do for that of soil. Your soil. Soil is a mixture. How do we know? Because it has the constituent elements of, your sandy soil, clay soil, your humus. And then there is no how your soil will not have water, there's no how it will not have air. Then I think that's all. Then I think we should add mineral salts. Mineral salts, So these are the constituents that makes up your soil. So now let me try to ask a question now. Let's call it sand. Is sand a mixture or a compound? Your sand. These are things you should know. Now you'll be thinking that sand is a compound, or sand is a mixture. Don't confuse yourself. Our formula for sand is SiO2 as silica 4 oxide. Are you with me? And this is a compound now. SiO2 coming from the combination of these elements, Si and oxygen, to actually give you SiO2. So why will you say it's a mixture? So sand is a compound. Are you with me? So let's check more mixtures. I think let me just give you the examples of mixtures that we have. So we have, under mixture we have our soil, our palm wine, our blood. You get our blood, our sugar. No, sugar is a compound, alright? So other examples of mixture now. Milk. Other examples of mixture now. Crude oil. You get crude oil, your Coca-Cola, crude oil, your Coca-Cola, your bras. These are examples of mixture. Let's try to check for the constituents of some of them. For example, these bras now, I'll use letter A, B, C, and Z to code it in. So this is my brass. My brass is the mixture of copper and zinc. So my brass, the constituent element of a brass is copper and zinc. As simple as that. Then Coca-Cola, what will be my constituent? The very first thing that I know that will be inside the Coke, a Coca-Cola, is my water. Are you with me? And then I can still tell you that, you know, it consists of a gas, you know, that will make the Coke do ch. When you open a Coke, when you go and buy Coke now, you hear ch. This is because of it's carbonated with carbon 4 oxide. So that means carbon 4 oxide is part of the constituent of a Coca-Cola. So we have, you know, my carbon 4 oxide, we have our Coca-Cola concentrate. It's actually giving the coloration and all of that. So then we would have our water. I think that's all. Water, sugar, yeah, sugar that will make it sweet. So now I think we are done with matter, nature of matter. So the assignment you should do for me is that you should write for me 5 differences between a compound, are you with me, a compound and a mixture. I need 5 differences, you know, where you'll be talking about this one is always homogeneous, while a mixture can be heterogeneous or, you know, homogeneous. Don't let me tell you the remaining answer. You guys should do the rest. It's your surgical medic, and he is what? Rooting for you always.